Hi everyone, in this video I'm going to show you how and when to apply the product rule and quotient rule when we are differentiating an expression. Before we start this video, do ensure you are familiar with the basic concepts of differentiation and chain rule in the earlier video that is linked in the description box below. So if you are ready, let's jump right in. Now let's try to differentiate this expression. In order to do so, we need to apply the binomial theorem to expand this function and multiply in the terms from this function and then differentiate them term by term, which is really tedious. So this is where we can use the product rule to find this derivative easily. In order to use this rule, do check that it is a product of two functions with a variable in each of them. Next, in your mind, identify two parts. The first part over here, denoted by u, and the second part over here, denoted by v. Start off by writing dy over dx, which indicate that you are going to differentiate y with respect to x. Very firstly, keep the second part, which is x squared plus 2x power 4. Then differentiate the first part, which is 1. Now the product rule starts with the letter p, so we'll put the plus sign. Next, keep the first part and differentiate the second part using chain rule, which is 4x squared plus 2x power 3 and 2x plus 2. We can then factorize the common term, which is x squared plus 2x power 3. Now to decide between 4 and 3, choose one which has the smallest power, which is power 3. Remove it, and we will have x squared plus 2x power 3 multiplied by x squared plus 2x plus 4, x squared plus 2, 2x plus 2. Simplifying the expression further, we will then have this statement over here. And by simplifying further, we will have a quadratic expression within the square brackets, which is x squared plus 2x power 3 and 9x squared plus 26x plus 16. Now, it is good to go one step further to factorize this quadratic expression, if possible, to give us x squared plus 2x power 3, x plus 2, and 9x plus 8. So this is the derivative of y and the answer to this question. Now let's try out some examples so that we can solidify our understanding of the product rule. We have an example over here, 1a, y is equals to 2x squared plus 1, x minus 3 power 6. Remember, identify two parts. Keep the second part over here, which is x minus 3 power 6. Differentiate the first part, which is 4x. Product rule starts with a letter p, so put a plus sign to join them together. Put the first part over here, 2x squared plus 1, followed by differentiating the second part using chain rule, 6x minus 3 power 5 multiplied by 1. Factorize the common term, which is x minus 3 power 5. We will then have x minus 3, 4x, plus 6, 2x squared plus 1, and close the bracket. And simplifying the expression further, we will have x minus 3 power 5, 4x squared minus 12x plus 12x squared plus 6. We will then have x minus 3 power 5, 16x squared minus 12x plus 6. Now try not to stop here. We can factorize 2 from this quadratic equation. We will then have 2, 8x squared minus 6x plus 3, and x minus 3 power 5. Now let's go on to the part b, where we see that there is a 2x plus 4 and a square root of x squared minus 5. Again, this is a product of two functions, but we can first write the surd in x squared minus 5 power half, which is an index form, so that we can differentiate this easily later. So writing dy over dx, we will have, remember, keep the second part, which is x squared minus 5 power half, multiplied by differentiating the first part, which is 2. Product rule starts with a letter p, put a plus, keep the first part of the expression, 2x plus 4, and differentiate the second part using the chain rule by bringing down half, writing x squared minus 5 minus 1 to the power, which is minus half, multiplied by 2x. Now be very careful over here. We are going to factorize the smallest common term, which is x squared minus 5 power minus half. It will be multiplied with x squared minus 5 power half minus half, because we are dividing each term by x squared minus 5 minus half. Multiplied by 2 plus x, 2 will have the following statement over here, which is x squared minus 5 power minus half, x squared minus 5 times 2 plus 2x squared plus 4x. We will then have x squared minus 5 power minus half, 2x squared minus 10 plus 2x squared plus 4x. And simplifying further by bringing down the power minus half, we will have 4x squared plus 4x minus 10 over square root x squared minus 5. Simplifying or by factorizing the numerator, we will have 2x squared plus 2x minus 5 over square root x squared minus 5. Now in summary, this is the general formula for the product rule. If you have gone through the exercises above, you don't really need to memorize it, but just remember the flow that we have been using. Identify the two parts, keep the second part, differentiate the first, keep the first, differentiate the second part. Connect them using a plus sign because product rule starts with a letter P. Now the product rule is used when we need to differentiate a function that is a product of two functions. Some examples where the product rule can be used are shown in the above, where there is a variable x in each of the two functions. And the two functions are a product of each other. In the last example, it is a function that is a product of two other functions. However, there are no variables over here, thus we can use the chain rule instead of the product rule to help us differentiate this. So let's introduce another rule that can help us differentiate an expression, which is a quotient of two functions. Now suppose you have this expression, which are quotients of two functions. We can then use the quotient rule to help us differentiate this expression. So let's try to differentiate y with respect to x in this quick example. In our minds, we will let u be the first part, which is the numerator, and v be the second part, which is the denominator. Now using this example, differentiate y with respect to x. So we start off by writing dy over dx, keep the second part, which is x squared minus 2, and differentiate the first part, which is 3x plus 1, which gives us 3. Now the quotient rule is expressed as a fraction. Remember, there's a line separating that fraction, so that line you can associate it with a minus. So in quotient rule, we put minus instead of a plus. Alright, keep the first part, which is 3x plus 1, and differentiate the second part, which is just 2x. Now the denominator will then be x squared minus 2 whole thing squared. The denominator is always squared in the quotient rule. I'll share with you the general formula later, but just remember the flow of this quotient rule. Alright, simplifying, we will have 3x squared minus 6 minus. I'm going to be very careful over here because the minus will affect the terms within the bracket. I'm going to open the bracket right now to have 6x squared plus 2x, close the bracket, over x squared minus 2 power 2. Simplifying, we will have 3x squared minus 6 minus 6x squared minus 2x over x squared minus 2 power 2. We will then have minus 3x squared minus 2x minus 6 over x squared minus 2 squared. Now we can then factorize out minus, which is equals to minus 3x squared plus 2x plus 6 over x squared minus 2 squared. So there you have it. This is the derivative of y when we use the quotient rule to help us. Now let's try out some examples so that we can be very clear on how to use the quotient rule. In part A of this example, we can apply the quotient rule because they are quotients of two functions. So let's try to identify the first part, which is the numerator, and the second part, which is the denominator. Remember, keep the second part first, which is x squared plus 2, and differentiate the first part, which is 3. Quotient rule, we put a minus, and keep the first part, which is 3x minus 7, and then differentiate the second part, which is 2x, over the denominator squared, which is x squared plus 2 squared. By simplifying the terms, and remember, be careful with the minus sign over here, we will then have 3x squared plus 6 minus 6x squared plus 14x over x squared plus 2 squared. We will then have minus 3x squared plus 14x plus 6 over x squared plus 2 squared. As we couldn't factorize the numerator anymore, we will then leave the answer as such. Now let's try to move on to part B, where we have a quotient of two functions. We have x plus 4 over square root x squared plus 6. Now take note that square root x squared plus 6 can be written as x squared plus 6 power half. So using this knowledge, keep the second part, which is x squared plus 6 power half, differentiate the first part, which is the numerator, and it gives us 1, minus, keep the first part, x plus 4, differentiate the second part using the chain rule, which is half x squared plus 6 minus half and 2x over square root x squared plus 6 squared. And this will give us x squared plus 6. So we will factorize out the smallest common term, which is x squared plus 6 power minus half. And this will be multiplied with x squared plus 6 power 1 minus x plus 4. Now, if you are wondering why is it power 1 over here, it is because we are taking power half minus half, which gives us a value of 1, all right, over x squared plus 6. Now, let's try to bring down x squared plus 6 power minus half into the denominator, and we will then have x squared plus 6 minus x squared minus 4x over x squared plus 6 multiplied by square root x squared plus 6. We will then have 3 minus 2x over the denominator x squared plus 6 and square root x squared plus 6. Now the quotient rule is used when we need to differentiate a function that is a quotient of two other functions. Some examples where this rule can be used are shown on the screen, where there is a variable x in each of the two functions. And the two functions are in the formats of a fraction or quotient. In the last example, we don't really need to use the quotient rule, as there are no variables in the numerator. But what we can do is to convert it to a non-fraction and differentiate it using the chain rule. Now in summary, this is the general formula for the quotient rule. If you have gone through the exercise above, you don't really need to memorize it, but just remember the flow that we have been using. Keep the second part, differentiate the first, minus, keep the first part, differentiate the second, over v squared, which is the denominator square. Now I do hope you have learned something from this video. If you'd like to polish up your skills, do check out the free practice questions and worked answers that are linked in the description box below. Do subscribe to my channel to see regular math videos so that you can level up your techniques. Thank you, and I'll see you in the next video.